When you send crypto from one wallet to another, it can feel almost magical, but under the hood, there's a very clear process happening step by step. So let's walk through how a crypto transaction actually works from start to finish. It all begins when you open your wallet and enter a few basic things: the recipient's address, the amount you want to send, and the network you're sending it on. At that moment, your wallet isn't moving any coins yet. What it's really doing is creating a transaction message that says, I want to perform this action on the network. In most blockchains, that action is sending value, but it's important to understand that a transaction doesn't have to be only about money. A transaction is simply an instruction that gets recorded on the blockchain. That instruction could be a payment, but it could also be publishing data, interacting with an application, posting content, or triggering some sort of on-chain logic. Once that transaction message is created, your wallet digitally signs it using your private key. This signature is critical because it proves to the network that you're authorized to perform that action without ever revealing your private key itself. The wallet then broadcasts the signed transaction to the network, where it enters what's often called the mempool, basically a waiting area for unconfirmed transactions. From there, validators or miners, depending on the blockchain, pick up the transaction and verify a few things. They check that the signature is valid, that the rules of the network are being followed, and that the transaction doesn't conflict with the current state of the ledger. If everything checks out, the transaction gets bundled together with others into a block, and that block is proposed to the network and accepted through the blockchain's consensus mechanism, like proof of work or proof of stake. Once the block is accepted, the transaction becomes part of the blockchain's permanent history, and the network updates its shared ledger across thousands of nodes worldwide. At that point, the transaction is considered confirmed. There's no bank approving it, no office hours, and no customer support agent pressing a button. It's just cryptography, math, and distributed agreement. This is exactly how Bitcoin itself was designed. In the original Bitcoin white paper, Satoshi Nakamoto explains that transactions are authorized using digital signatures, allowing the network to verify ownership without revealing private keys. Quick pause here. If this breakdown is helping you actually understand what's happening when you click send, take a second to subscribe, because this channel is all about making crypto concepts clear, practical, and easier to understand. Now, back to transactions. One thing many people don't realize is that on some blockchains, transactions can do much more than transfer funds. For example, on Qortal, a transaction can include publishing data to the network, such as a blog post, a video, a message, or even an application. Instead of just saying send value from A to B, a transaction can say store this content on the decentralized network, or post this message to a group, and that instruction is then verified and recorded just like a payment would be. That's a powerful shift because it also means the blockchain isn't only a financial rail, it's also a coordination and data layer. Confirmations also matter. A transaction becomes much more secure the more blocks are added after it, because each additional block makes it increasingly difficult to alter the history. Fees play a role as well. Fees are incentives that encourage miners or validators to include your transaction in a block, especially when the network is busy. Higher demand for block space usually means higher fees because space in each block is limited. This is more popular on the Ethereum blockchain. Whether you're sending money, publishing content, or interacting with an application, the same core process applies. A signed instruction verified by a decentralized network and recorded on a shared ledger. Once you understand this flow, a lot of things suddenly click. Why private keys matter so much, why wallets don't actually hold coins, why decentralization works, and why blockchains don't need permission to function. In simple terms, a crypto transaction is a signed message that tells a network to do something, and that message becomes part of a permanent verifiable history. That simple mechanism is what makes peer-to-peer digital money, decentralized applications, and censorship-resistant networks possible in the first place. If you want more explanations like this that actually build a real understanding, make sure you're subscribed. There's a lot more coming your way.